on how many variables? One variable. Then the derivative of f with respect to x denoted by right? We write df upon dx. Abdul Malik, now focus here. Dear Abdul Malik, my child, focus here, okay? We will talk all the things later on. Okay? This is Abdul Malik or Abdullah? I can read your name correctly or not? See, Abdul Malik, when your function depend on one variable, how many variables? Only one. Then we denote the derivative of f with respect to x with this symbol df upon dx. Okay? Now your f is depending on more variables. Like 2, for example, 2. How many variables? 2 or more. How many variables? 2 or more variables. Then we denote the derivative of f with respect to x with this d del f upon del x. Del f upon del x. Is it visible on your screen or not? Hello? How much part is on your screen? Can you tell me, please? When I press it, so does it affect? Okay, now full screen. You cannot see Ali? Ali? The screen is small. Now? No effect. Okay. Give me 1 minute. Sorry. Now? Now? Just a moment, please. Now? Okay, thank you. This was I was asking to you. Thank you. Other joining or not? Is any update? Where is Bandar today? Bandar. Good morning, Bandar. Bandar. See, f is depending on how many variables? You can see two variables, x and other is how much? Y. X and y. So when we differentiate f with respect to x, so this is called partial derivative, because f is not Kullu differentiating. F is depending on x, y. So you are differentiating just, with respect to x. So this is called partial. This is called partial. For example, if some question is for 10 marks, okay, and if you done some step correctly, then how many marks given to you? Partial marks, not full marks. How much? Partial. So this partial is related that. So you are differentiating with respect to x. So this is called partial derivative of f with respect to x and denoted with this symbol, del f upon del x. So what does it mean? This is the partial derivative of f with respect to x. This is what? The partial derivative of f with respect to x. Okay? Everyone understand? Good. Great. Where is Abdul Aziz Al Jabbar today? He's with us or he's not? I think he's, yes. So del f upon del x is defined as limit s tends to 0 fx plus h comma y minus fxy upon h. So you can see just you are changing x. Y is here y and here is also y. You can see nothing is changing. So this is called the partial derivative of f with respect to x. Similarly, partial derivative of f with respect to y. So when we differentiate partially with respect to x, then we treat y as a constant. If we differentiate x with, if we differentiate f with respect to y, then we treat x as a constant. Simple. Please note down this. Are you noting down? Okay, please. This is also written as fx. This is written as fy. Okay, my childs. Muhammad Al Dafari. Where is Muhammad Al Dafari? So don't be confused. Don't put this symbol. When you write this symbol means it's a total derivative. So don't use this symbol. Okay. So you will write either fxxy or fy. Please note down this question. Nana. Noted. For f, this is your f. Okay. We need to find the partial derivative of f with respect to x, with respect to y, and these partial derivative we need to find at 1 0 and 2 comma minus 1. All right. C. Compute del f upon del x by treating y as a constant we have. X and y are the independent variable. It should keep in mind here. X and y are the if your variables are independent, then we treat other as a constant. If you differentiating with respect to x, then as a constant. If we are differentiating with respect to y, then we treat x as a constant. Okay, that's fine. Look at here. So del upon del x, del f upon del x equal to del upon del x, and this is the value of f. Now see, we can write it as 3 del upon del x x square plus y del upon del x x cube plus del upon del x 4y square. Is that clear? Just we enter the operator. Okay. Hello. Okay. See, this is the formula del upon del x of x to the power n. This is how much? Do you know this formula from calculus 1? Derivative to the power n is how much? Nx to the power n minus 1. Right? Right, Suleiman? So this derivative will be 3, and derivative of x square is how much? 2x plus y. Derivative of x cube is how much? 3x square. And derivative of 4y square is how much? 0. Okay? Okay or not okay? Is it okay? Khalid, you are great. Not? Who is this? Suleiman? What is the problem? Please tell. You can turn your mic, not an issue. Please ask. Salman? Yeah, please tell. I cannot read your name actually. I'm sorry. You know, I spent 7 years here, and because y is a constant, you are differentiating with respect to x, then you treat y as a constant. And we know that the derivative of a constant is 0. Derivative of a constant is how much? 0. Yes, so this value is 0. So 3 into 2x is how much? 6x, and 3x square y. Ali, clear? Ali. Ali, Muhammad Ali. Is it clear? Mr. Ali. Where is Abdul Aziz today? He's preparing the coffee. Can you find this with respect to y? Could you please able to find it? This one. Bandar, where is Abdul Aziz? Bandar, Mr. Bandar, where is Abdul Aziz? It is not looking here. Send a message to join immediately. Bandar, now find del f upon del y. Ibrahim, Ibrahim. Okay, try it in a minute. Within 30 seconds, I need an answer. Write your answer in the chat box. XQ. MashaAllah, MashaAllah, MashaAllah. Very good, very good, very good. Excellent. You have done a great job. 2 marks from my side to you guys. Ali and Bandar. 2 plus 2, 4. And this is Ibrahim. MashaAllah, Ibrahim. Ibrahim Muhammad. Yes, I told you 2 marks for you, Mr. Ibrahim. You are my favorite student, you know. Abdul Malik, you are slightly late, but still 2 marks for you also. Very good, Abdul Malik. Great. You are doing great, Abdul Malik. Abdul Malik. Now we need this. I know how much I am your favorite. You always not happy with me. Always said, doctor, you cut my marks, you reduce my marks. So this is your x cube plus 8y. This is your answer. Now we are trying to find fx10. Do you know what is your fxxy? How much is your fxxy? 6x plus 3x square y. Okay. To find this, so what we need to do? Just plug in x equal to 1 and y equal to 0. Just what we need to do? Plug in x equal to 1 and y equal to 0. So we get fx10 equal to 6 times of 1 plus 3 times of 1 square into 0. So 6 into 1 plus 0. So this is 6. Understand? Abdul Malik. Good. Good, Mr. Ali. Where is Saleh? There is a Saleh and Omar Al Omar and Suleiman and Abdul Aziz. There are only one Abdul Aziz in this class. And Khalid Suleiman, Khalid Ibrahim. Where are all the guys? Yes, Suleiman. I called you several times, but you did not respond me. So I was thinking I'm reading your name incorrectly. Okay, thank you, Suleiman. Suleiman. Now what we need? Fy 2 minus 1. Means plug in x equal to 2 and y equal to minus 1. So this will be 2q plus 8 into minus 1. So this will be 8 minus 8. So this is how much? في فهم؟ The rules in the partial derivative like as the rules in the ordinary derivative. So please note down these two rules. The derivative of product of two functions is equal to अव्वल इस्तकातानी मुजब तानी मुस्तकात अव्वल. First into derivative of second plus second into derivative of first. Noted? Ali. Mr. Ali. Noted? Can you see this question? Computing partial derivatives. Note down this question, please. Muhammad, you are welcome. Noted? C. Find del f upon del x. So del f upon del x is that clear? This is the value of f, just you put here. So this will be e to the power xy into derivative of xy. This is clear, this one? What is the derivative of xy with respect to x? Fine. Is it okay? Similarly, we can find the derivative with respect to y. Similarly, with respect to y, so del upon del y e to the power xy plus xy to the power minus 1. So we can write e to the power xy derivative of, so this is x e to the power xy plus xy to the power minus 1 y to the power minus 2. So x e to the power xy minus xy to the power minus 2. So we can write it as x e to the power xy Is that okay, Ali? Mr. Ali, Mr. Bandar, Mr. Suleiman, Mr. Muhammad, Mr. Bandar. If you can do this question, 50 marks for you. Can you do this question, all of you guys? Yeah, try it, try it. Inshallah, 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 A plus. Inshallah, inshallah, A plus plus. e to the power y square plus 2 plus y square minus t square plus x plus y. Bismillahirrahmanirrahim. Auzubillahi minash shaitanir rajim. Maficois. We don't need integral. Mr. Ali. We are interested for the partial derivatives. Mr. Ali. And the integral is also not correct. Mr. Bandar. Mr. Bandar. We are interested for the partial derivative. If you can do it, get how many marks? 50 plus. Can you do it? Muhammad, both Muhammad are here. Ali, Abdul Malik, Abdullah. Abdullah, welcome. Suleiman, Bandar, and this is Ibrahim. Yes, second I cannot read. What is this name? This is Baba Basa. Baba Basa, is he here or not? Baba Basha. Where is Baba? Bandar, where is Baba? Basil. I was thinking this name is starting from B. Basil, how are you? Basil? Basil is now good. He just need not to attend the lecture. Just turn on the sign on and go to bed again. Basil? Basil? Fx equal to y. Mashallah, mashallah, mashallah. You are the gem. You are the gem. But هذا ما في كويس. هذا ما في كويس مستر. Na Abdul Malik. هذا معلوم formula. If you're 1 minute. Okay, I'm giving this hint. You will try at your home. If Ix equal to Pt to Qt, no Px to Qs. Here Kxt dt. Then di upon dx equal to Px to Qx del k upon del x dt plus k x qx into del q dq upon dx minus kx px dq upon dy. This is the formula. Apply this formula and get answer. This was with you in the calculus 1. You did not study in the calculus 1? Calculus 1. Calculus 1 4 years ago. MashaAllah. What about Ali? Mr. Ali, Mr. Bandar, Mr. Muhammad. You study this formula or not? So apply this formula and get the result, okay? First time I see. It means your teacher skip this. I'm getting task for your home, but if you try it from your home, you will get. You want to see some applications? This is known as van der Waals gas equation. Baba. This is what? Van der Waals gas equation. P is the pressure, V is the volume, and T is the temperature. P is what? Pressure. V, volume. And T, temperature. And R, N, B, A, all these are the constants. A, B, R, N. All these are the. This is what physics. For a real gas, van der Waals equation states that pressure plus N square upon A upon V square into V minus NV equal to N times of RT. Okay? Okay, mister? Is that fine? Mister? Note down this, then we will go for next. Where P is the pressure, V is the volume, T is the temperature in the Kelvin, N is the number of moles of gas, R is the immersion constant, and V are the constant. Compute and interpret. We need to compute and interpret all these. Noted or not yet? Look, what is your equation? You want pressure and temperature. Here you need the derivative of pressure, and here you need the derivative of temperature. You have two options. Either you write P in terms of or you write P is a function of what? Here, volume and temperature. And temperature is a function of pressure and volume. Okay. So we can write it as, can you see this, my boys? Can you see this? I'm writing here. Okay. Is there any problem? If we divide the whole equation with V minus NV, is there any problem? Is there any problem? Okay. So what happened? This is V minus NV and this is also V minus NV. So what happened? Hada. Ro और बर्रा और मुतलक. So you get rho. Okay. So P plus N square upon A V square equal to nRT upon V minus NV. Okay. Okay, mister. Is that clear or not? So we can write it as P equal to nRT upon V minus NB minus N square A upon V square. Is that clear? Now your pressure is in terms of temperature and volume. Temperature and in terms of volume. Okay. So your pressure is in terms of temperature and volume. This. You need here derivative of P with respect to V. So we treat T as a constant. Right? Right or wrong? So del P upon del V equal to this. So we can write it as nRT del upon del v minus nb whole power minus 1 minus n square a del upon del v to the power minus 2. Okay? Okay or not okay? So this power is, so we can write it as, can I write here? Can I write here? nRT. This power is how much? This power is how much? This power is how much? Minus 1. So we can write it as minus 1 v minus nb whole power minus 2 del upon del v minus nb minus n square a into here. This power is minus 2. So we can write it as minus 2 v to the power minus 3 right. Hello, hello, hello. So this is minus, so this minus makes minus nRT, and this power is minus 2, so we can write v minus nb whole square plus 2 n square a upon, this is minus 3, and this is minus, so minus minus become plus, so this is 2 n square a upon vq. All right. Okay or not okay? Understand? Is any problem? Yeah. Now you need the temperature with respect to P. Temperature with respect to P. So similarly, you can write the temperature here like this. This is your equation. P plus n square A upon V square V minus NV equal to, this is your equation, van der Waal equation. Okay. Okay or not okay? So both side divide with NR. So we get this cancelled. So temperature T equal to 1 upon nr p plus n square a upon b square b minus nb. So now very simple, when we differentiate with respect to p, so you can see only one function for p, so its derivative is how much? 1. For this, the derivative is how much? 1. So just left 1 upon nr p minus nb. You know what is the meaning of this? When we say del P upon del V, this is the rate of change of pressure with respect to volume. This is the rate of change of pressure relative to change of temperature relative to change in pressure. And when we say del T upon del P, this is what rate of change in temperature relative to change in pressure. Okay? Okay or not okay? Mr. Abdullah. Where is Abdullah today? I have not seen from the morning. Abdullah, how are you? See this question. Now we will go for the higher order derivatives. You want a break? Or we shall continue? Continue, right? What does it mean? Yes. Break? Okay, let's have a 10-minute break. Okay, please take rest. Okay, take coffee, use mobile. Thank you so much. Thank you. Thanks a lot. Welcome back. Hello. Welcome back. Mohammed, we are talking about now higher order derivatives. Higher order derivative. Till now, what we have done? We have done the first order derivative. First order derivative means if your f depend on xy, so its first order derivatives are del f upon del x, del f upon del y. Or we will write this fx and we will write with fy. Now the higher order derivatives are means if we differentiate this f with respect to x again, then how much we will get del 2f upon del x2, del 2f upon del y2, and del 2f upon del x del y, or del 2f upon del y del x. This is the second order derivative, and we denote them. This we denote with fxx, fyy, fxy, fyx. Okay. Okay or not okay? क्या शोर मचा रही हो? Hello. Hello. So these are the higher order derivatives. Look at here. Can you see this? What we need? You cannot see, Suleiman? We need the second order derivatives. All second order derivatives are these are all second order derivative. Generally, if your function, if f is continuous, then del 2 f upon del x del y to del 2 f del x. Okay. Okay or not okay? So how we can find it? Look, to find del 2 f upon del x2, this is equal to del upon del x of del f upon del x. So we need this first, del f upon del x. So del f upon del x equal to del upon del x x square y minus y cube plus ln x. Is that clear? Hello? Is that clear? So with respect to x, what is the derivative? 2xy plus 1 upon x. This is your del f upon del x. Again differentiating partially with respect to x. So del upon del x of del f upon del x. And what is the value of del f upon del x? This is the value of del f upon del x. So just plug in here. So del upon del x 2xy plus x to the power minus 1. So this is 2y plus minus 1 to the power x minus 2. Okay? Okay, mister? Fine or not fine? So del 2 f upon del x2 equal to 2y minus 1 upon x square. This is your del 2 f upon del x2. Now we need del 2 f upon del y2. Del 2 f upon del y2. This. So del 2 f upon del y is equal to del upon del y, del f upon del y. So find the second derivative. We need first the first derivative. We need del f upon del y. So del f upon del y equal to del upon del y, and f is x square y minus y cube plus ln x. And what is the derivative with respect to y? This is x square minus 3y square. This is your del f upon del y. So del 2 f upon del y2 equal to del upon del y, del f upon del y. So we can write it as del upon del y, x square minus 3y square. So we can write it as minus 6y. This is the value of del 2 f upon del y2. Okay. Hello. Sir. Sir, my officer. For example, if you need del 2 f upon del x del y, so this is equal to del upon del x del f upon del y. So this is del upon del x. Del f upon del y is how much? So just plug in this value. Where? Here. So this is x square minus 3y square. So this is 2x. This is your del 2 f upon del x del y. If you want to know del 2 f upon del y del x, this is equal to how much? Del upon del y del f upon del x. And del upon del y del f upon del x is how much? Del f upon del x, 2xy plus 1 upon x. 2xy plus 1 upon x. With respect to y, its derivative is how much? 2x, and it's 0. So this is how much? 2x. And earlier your del 2 upon del x del y equal to how much? That is also 2x. You can see from here. This is how much? 2x. So from here you have all the second order derivatives, like del 2 f upon del x2, del 2 f upon del y2, del 2 f upon del x del y. All the derivatives you calculated. Okay, Mr. Muhammad, can you find where is your name written on this board? Mr. Muhammad. Mr. Muhammad. Mr. So you understand or not? You want to note it down? هذا صوف ما في صوف. صوف. Hello. Hello, Charlie. Hello. Can you see this? What is written on the board? Okay. So you want to note it down, or shall I go for next question? Shall we go for the next question or you want to note it down? One minute. Okay. Abdul Malik, you are so gentle. You are the gen. Hello, hello, hello. No one ask anything if I will not ask. No one ask. So let's go for another question, or still you are noting? You can go. Thank you for giving me the permission. I am so thankful to you, Mr. Abdul Malik. Let's go to exercise directly, okay? Let's go to exercise quickly. So, Bismillahirrahmanirrahim. I think we have done. We have done. Let's look the higher order with some example. I think so. Can you see this question? What is written on your board? If you read it, 1 marks for it. Suleiman, can you read this? What is written? Yes, read it. Read it. Suleiman, quickly. He is telling he can read. Now, 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 now. He is Superman. Suleiman, you are Superman. Which question you want from me? Which question? Tell me. Tell me. Tell me fast, within a second. 11. MashaAllah. You asked me the easiest one, so I will do this. But I'm not going to ask you easy question, okay? It is not your choice. This is the time for your choice. Later on in my choice, okay? Don't tell me, doctor, you. Del f upon del x is equal to 3x square minus 4y square. Del 2f upon del x to equal to how much? 6x. Del f upon del y equal to how much? Minus 8xy plus 3. Del 2f upon del y to equal to how much? Minus 8x. Del 2f upon del x del y equal to how much? Del f upon del y. So this is del upon del x. Del f upon del y is minus 8xy plus 3. So this is how much? Minus 8y. Del 2f upon del minus 4y square. So we are getting minus 8y. Class. This is class. Okay. Okay, Mr. Suleiman. في فهم؟ في فهم؟ Hello. 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 Hello, my son. You have done? Okay. Which question you want from me now? But I will ask you not easy question, okay? Okay, do 12. For you 12. If you do 12, you get how many marks? 1 plus 2, how much? 3. So you get 3. If you do 16, so 1 plus 6 equal to how much? 7. This is 6. This is 5. This is 4. This is 3. This is 2. Okay, ready? Do it quickly. Dear students, there is a quiz for you. You can attempt it, okay? I think you get the notification yesterday. Did you receive any email for the exam? Okay, so please attempt that. Thanks a lot. Take care. Stay safe.